Many ancient cities around the world are filled with buildings made of brick, with official dating starting from the 15th century. Instead of engineers figuring out what technical means were used for construction, historians prefer to admire the artistry of ancient architects. Those who are involved in construction and finishing know that buildings constructed in the early to mid-20th century are usually made by eye and by hand, more or less approximately. Our measuring instruments don't really help to align everything, since even the walls can be set at an angle. And if you carefully check the radii on modern buildings, you'll find that they aren't made exactly accurately either. High-rise buildings are also a bit crooked at the top. The vertical deviation can be up to 20 centimeters over 2 or 3 floors. But this isn't really critical, there's nothing terrible about it. In new buildings, small wall cracks and minor issues are acceptable and generally not problematic for the overall structure. Let's take a look at how modern buildings are constructed. First, piles are driven in, then a slab is poured for the foundation. Next, a monolithic steel and concrete structure is built. Low-rise construction uses the same foundation with a reinforced concrete belt. The main feature of this type of construction is speed. An 18-story building can be assembled in just a few months. This is of course an advantage, but at the same time, there are a lot of drawbacks. The apartments have rather thin walls. Basically, in winter we're heating the street. That's why in cities the temperature in winter is a few degrees higher. In China, buildings are designed to last 30 years before being demolished, and the process starts anew. Now let's move on to brick houses, which according to historians were built in the 15th to 17th centuries. Let's see how they differ from our construction methods. It became interesting to see how the Nizhegorodsky Kremlin has stood on the edge of the slope since the 15th century. At the same time, the clay slope hasn't slid into the river in all these years. In one article, a scholar writes a strange story. It turns out that under the wall there is a massive slab made of rubble stone. That sounds odd. A pile of stones can't be a slab. We make such embankments for roads. They are compacted in layers with multi-ton rollers. However, potholes often appear on roads, so comparing foundations and embankments is somehow unreasonable. This is the first difference. Over 100 or 500 years, stone embankments, it will definitely cause uneven settling, and the walls will crack. Even a settlement of 5 centimeters will be enough. Modern builders know this. The next difference is the mortar for laying bricks. We make mortars based on cement, while they use lime. Such mortar hardens very slowly. The liquid lime mortar reacts chemically with carbon dioxide and hardens as a result. And the width of their masonry is from 1 meter or more. This means that inside the masonry, the lime will harden very slowly over several months, and if the foundation is weak, the wall will crack. To prevent this from happening, you'll have to lay the bricks very slowly. Lay a couple of rows and wait a couple of weeks for it to harden. It's unreasonable. These 3 or 4 floors could take several years to build, considering the construction volume. We have evidence that in the 15th century they used some kind of chemicals for rapid hardening. Next is the masonry. We mostly build straight boxes, but our predecessors could and did build very complex structures. Even ordinary small houses were built with arches, vaults, and a large number of brick decorations. For us, it's costly, complex, and lengthy. And we also must not forget that the building is on a weak foundation, and during this construction, we always need to remember that the building stands on a weak foundation and the mortar gains strength very slowly. And so, we come to another mystery. Of course, this mystery is not for everyone. One of the many scientific myths is that the mortar was made with eggs. For such construction, precise measurements of the wall levels are needed. Any deviation leads to the destruction of the walls even during the construction process. Surely many have seen or at least heard about how a beautifully built house, seemingly constructed according to all the rules, suddenly split in half. It's clear that unqualified masons are to blame for this. The house is built without a proper design, but rather based on so-called cheerful pictures. There's a foundation, there's a reinforced belt, but cracks appear along the wall. Now, during construction and finishing, as a rule, 2 16-beam laser levels are used. This is a laser level with beam fixation. Well, and other devices too. There is such a thing as fractal geometry and Lobachevsky's geometry. That's the guy who came up with clever formulas and laws. Now we have levels and lasers lying on curved surfaces, contradicting mathematics. This causes a lot of trouble for inexperienced finishers. So how do you get out of this situation? Yes, it's very simple. Where possible, use a string instead of a compass or bend a plastic pipe to the required radius, but that's in small rooms. They showed on television how lasers can draw any building with any surfaces in the air. It would be great to build on them later. It seems magical, but it's costly for now. And here's another method. Kamenchik, so you don't waste time measuring levels, puts a template made of boards in the future openings. You can determine the vertical level using plumb lines. It's simple. For the horizontal, a few plumb lines are enough too, but this applies to working with small rooms. For a length of 30 to 50 meters, you need a good optical instrument, and you also need very strong threads. Even now, not every nylon thread will work for this problem. They stretch and sag by several centimeters. However, this problem didn't exist in the 15th century. Now you can find it for sale, but it's hard to find in a fishing store. And you have to use this when the work is being done in a room that's more than 70 meters long. All other tools have an error margin of 3 to 5 centimeters. So, in other words, you can't do this with just a simple string. Maybe there was some clever secret that builders today don't know about. And you also need a project. If it's a small house, some super skilled mason might be able to put it together just by looking at some fun pictures, but he won't be able to build a large building that way. Since multiple crews will work there, each with their own mortar joint thickness. In brickwork it might seem unnoticeable, but even a difference of 1 millimeter gives you a whole centimeter over 10 bricks. And what if it's 50 bricks? As a result, nothing matches up with anything. And let's make the task more complicated. When constructing a building with complex geometry, even more precise measurements and control are needed. That's why a project is essential in this case. In the project, you need to account for the brickwork bonding and observe many other technical details. If you don't take all this into account in advance, the house will simply fall apart during construction. That means you need a project where every row of bricks and the sections of important joints are specified. All this is needed not only for the builders. And here's another thing. In these buildings, bricks of different shapes and sizes were used. But how do you calculate the amount of different bricks, their shapes and sizes? So what? Do you need to build a factory nearby with a full assortment of bricks? Again, each person needs a project where every row of masonry is specified. So that was the theory. Now let's move on to practice and build a house, but without modern tools and techniques. When iron was in short supply, wars were fought over it. And this is not made up. This is what historians write. This is exactly how the 15th century is presented to us. Imagine that you are some kind of boyarin. An idea came to mind to set up a family estate. Finances are all in order. You saw that the neighbors have a big house, but you need an even bigger one. About 50 meters more and some utility buildings. And here's the first problem. You'll have to hire a brilliant architect. But from where? Naturally, from Italy. Otherwise, people won't understand and it won't be recorded in history. One might assume any Italian architect from a tavern could do the job. The most brilliant one is chosen and construction begins. The first problem, a foreign architect. But in reality, everyone is supposed to speak perfect Russian and understand the metric, imperial, old Slavic systems and others and convert data at the speed of a calculator. To know European and Russian standards for construction materials and the grades of metals used in technology. The project has been approved. Let's proceed. We need a drawing for each row. How many sheets of paper, each half a meter by a meter, do we need? Let's use a scale of 1 to 10. We'll add all the nodes and sections. We have 4 floors, at least 15 meters of layout. Let's calculate, that's about 5 to 6,000 sheets of paper. If you're skeptical, try it yourself. Get a pen, ink, and rough cardboard. The drawing should be as small as possible while remaining readable. At the same time, you have to remember that the project is not made in a single copy. Next question. How many people and how much time is needed to draw everything? And not just scribes, but specifically specialists who understand masonry. Specialists need to calculate the load and other nuances. Well, at least 5 people with higher education and another 5 to 10 with less qualification. That's by our standards. Now the next question. Did he bring them with him or are they locals? If there are such locals, why do we need foreigners? Building construction involves not only brickwork, finishing, and painting, but also windows, staircases, furniture, fireplaces, and stucco. Who did this and when? It was assembled in Italy, disassembled, transported, and reassembled here. The craftsman team of 20-50 people would come to us, requiring living quarters, workshops, and tools. And we remember that just for making and storing a single project, we need a huge building. Historians will tell us that this was done by serfs, but if we still think that serfs couldn't have done this, then migrant workers from Italy lived here for several years, so according to us, half of Italy lived in Russia. Some of the people had to stay, they got married. These free and skilled craftsmen were meant to leave a historical mark, but history bears no record of them. There is a German quarter in Moscow, but there isn't an Italian one. Well, since they were Europeans, maybe the men didn't love women, they loved men, and that could explain it. Why are there no traces left? Let's focus on the foundation construction. We build a robust slab using rubble stone with a minimum width of 1 meter by 1 meter. It requires at least 300 cubic meters of stone, which is a minimum of 600 tons. A quarry within 18.64 miles is manageable, but hauling stone on horses from a quarry 124 miles away would have been challenging. If we start calculating the number of carts and the expenses for them, we'll be shocked. That would simply rule out any possibility of construction. What will historians say to us? People accumulated wealth by having many serfs, who were essentially slaves, and managed to get by. Next, we require specific building materials: bricks, lime, lumber, nails, staples, and other consumable items. If we look at our time, we have different kinds of clients. Some listen to the requirements, while others do things their own way. It seems like you can buy everything on the store shelves. Some items for apartment renovation can be purchased immediately, while others have long delivery times, prolonging the renovation process. And there's nothing you can do about it. That's the market and its laws. And now let's go back to the 15th century as our historians describe it. Russia had just freed itself from the yoke, and the Moscow princes became the main rulers in the country. The majority of the population are peasants. Mostly, these are small towns and settlements. Industry consisted of primitive blacksmiths and brick production. They kneaded the clay with their feet and sun-dried it. How they made fabric is actually a mystery. They used some of the simplest hand tools. And suddenly, someone decided to build a big house with all the finishing touches. As we remember, the house was 100 by 50 meters. That's about 4,500 cubic meters of bricks, lime not counting the plaster, 450 cubic meters, and several dozen cubic meters of boards. Here is where small problems start to arise. When they were building the Nizhegorodsky Kremlin, they collected bricks from all over the area, as historians write, and it's unclear where they brought them from, whether from nearby villages or neighboring towns. In every locality, there were small brick factories to meet the needs of the population. In historical sources, you can find information about how bricks were made in the 15th and 16th centuries. If you familiarize yourself with this information, you'll come to understand that for buildings to last 500 years, such bricks would not be suitable. Here, you need technology that's as good as modern technology. Firing should be done at 1200 degrees, and this process takes from 2 to 3 days. In a standard kiln, 2 to 3 cubic meters of bricks are produced in 3 days. We are told that after molding, the bricks were dried in the sun. This means that bricks were produced for no more than 3 months a year. To produce such volumes, one kiln is not enough. You need to have 2, 3, or even more. Such a workshop could then produce 270 cubic meters in one season. And all of this goes to meet local needs. In this case, construction could take 20 to 30 years. Or you just need to increase production several times over, and here again problems begin to arise. You need to build many kilns for firing, hire and train staff, buy additional tools, and find coal. That's a lot of coal, and after the order is fulfilled, all of this will no longer be needed. No sane person would work at a loss. This concerns mining, firing, lime, charcoal production. Somewhere, you need to find a lot of blacksmiths, extract and smelt iron, and again you need coke bricks. Transport everything using extra horses, carts and sleds. Provide hay and grain for the horses. And this wheel of problems keeps rolling like a snowball. In fact, long-distance transport makes all materials as costly as gold. And even if all this is somehow provided, it will turn out. According to historical data, the population size and density during that era was so low that in order to somehow make all these ends meet, one would have to assume that women, children, and the elderly all participated in these processes, and it would also be necessary to invent some other layers of the population. Either all of this was built using a highly technological, automated, robotic, computerized method with the use of equipment similar to modern technology, or perhaps even much more advanced. Yes, some researchers put forward this version, looking at what was built in the Middle Ages. So, let's return to the construction of that era according to the official version of history. We need to build a building 100 by 50 meters with walls more than a meter thick and with the most complex geometry. How many skilled stonemasons do we need? A 5th grade stonemason lays from 1.5 to 1.5 cubic meters of brick per shift, depending on the complexity. They take 1.5 cubic meters and multiply it by 360. It turns out that in a year, one person lays 540 cubic meters, and 10 people in a year will build a house like that, just like it really happens. The building's complex geometry limits progress to a cubic meter per day. Can construction workers work on site 360 days a year? Definitely not, only when it's above zero outside and there's no rain, so that's 90 days a year. And if it's no more than a cubic meter per day, that means 90 cubic meters for the shell, 4,500 cubic meters, and about 1.5 to 2,000 cubic meters for the interior walls. Let's sum it up. How much time and how many people do we need? For this, we'll need hundreds of horses, carts, and people to take care of them, feed them, and drive them. We'll need at least 50 workers like that. A brilliant architect, one person, and at least 5 or more people to draw up the plans, preferably with higher education. Experienced masons who know geometry and algebra, more than 10 people, carpenters and roofers. 10, also with education, plasterers, painters. Someone also has to craft the furniture, stairs, window frames, and doors, following Italian designs. And a space is needed for storing and drying lumber. This is a large space, a workshop. They often made stone tiles for the floor, and these are also specialists. All of them need tools for cutting and polishing stone, a space where they will work, a room for designers to work, and to store several thousand sheets of project plans. All of this needs to be guarded so it isn't taken away for firewood or used for building people's own houses. A quarry extracting and crushing rubble stone with shovels, pickaxes, sledgehammers, hammers, wedges, horses, carts, and horse feed. And where is that quarry where they can manually produce 300 cubic meters of stone a year? How many people should work there? No fewer than 20, and they also need clothing and shoes. What about the preparation and firing of lime? It's all the same, except you have to add kilns for firing, which need to be regularly repaired and maintained. You also need charcoal, and that means you need people to fell the forest and make the charcoal. You need horses and feed, tools, axes, saws, shovels, shoes, clothes, and you need construction timber. Sawing logs into boards is a familiar experience for those who have done it before. And without modern equipment, for all this, you need strong iron tools to extract and smelt iron, and to produce a huge amount of quality tools. Let's not forget, we are now in the 15th century, and again you need bricks and coal, clothes and shoes, you need experienced blacksmiths, dozens of them with good tools. Brick production is hundreds of cubic meters per year, and not just any brick, but our brick is made to order, of different shapes and sizes, and with very high quality firing so it can withstand all that weight. It all goes in a circle. You need coal, tools, clothing, shoes, etc. If only that was all. Now logistics. We need to transport hundreds of tons of cargo using horses, carts, sleds, horseshoes, and harnesses in the hundreds of thousands. Someone has to make the sled carts, tan the leather, sew the harnesses, road repairs. Hundreds of horses travel along the roads and people guide them. It was good if, in those times, all the territories were crisscrossed with roads, straight, not overgrown with forest, the kind that researchers often mention. That could explain transporting so much cargo. But what if it wasn't the case? People need somewhere to sleep and something to eat. When horses are under physical load, they need to eat 5 to 6 kilograms of oats and 10 to 12 kilograms of hay per day. We have hundreds of them on the road, and we must prepare and deliver the feed to the correct location at the precise time. Someone has to manage all of this. And all of this is caused by the construction of just one not so big building, only 100 by 50 meters. This data is quite real, some of it even underestimated. You can calculate it in kilograms, cubic meters, rubles, factories, and people. Numbers don't lie, it's evident and anyone can verify it. But in reality, all of this could turn into a pretty solid doctoral dissertation the size of a book. Officially, nobody will ever be assigned this task. They'll ensure no one even considers doing it. And now we've come to an interesting question, one that historians keep silent about and no one researches: how the Kremlin in Nizhny Novgorod was built, one of the many similar structures all across Russia. They collected bricks from the surrounding area. It was like gathering them from dumps in neighboring towns. Let's uncover the history of these neighboring towns, and not just the neighboring ones, but also other settlements. And everywhere during that time something was being built. But how many buildings were destroyed during the Soviet era? Many of them were half destroyed by some kind of catastrophe and had to be demolished. And how many buildings were destroyed in the 19th century? We can only guess about that. Here, we're talking about thousands and thousands of large structures. And how many small ones? We find them both in villages and in abandoned places. All those estimates can easily be multiplied by thousands, or maybe even more. How many literate people must have lived in a backward country? For that, you need schools and universities. You need paper in enormous quantities. Thousands of tons of cargo were transported by horses. How much energy was needed for production? And all of this was done with charcoal. So it turns out, after analyzing the construction technologies of the 15th century for just one building, we come to the conclusion that all of this is nonsense. As shown in our history, they simply couldn't have built like that. Crucially, everything constructed was not limited to Russia, but also around the globe. In those centuries, people simply couldn't have built it for the simple reason that there wasn't such a large population in the world. And in order to build everything that has already been constructed, taking into account what was also destroyed, a civilization with a population larger than the modern one would have been needed. Analyzing the structures built in the past, the existing and still surviving antediluvian cities, and those territories that were destroyed but previously inhabited, modern researchers believe that the previous civilization had a population larger than the modern one, while being at a high level of technological development.